Does biology really have nothing to do with quantum physics? Okay. If you like to read more about the importance of quantum physics for our life, I can recommend this book to you, Infinite Potential, What Quantum Physics Reveals About How We Should Live. I'm very grateful to Deepak because he helped me to publish it. Okay. Biologists, they often claim that their science has nothing to do with quantum theory. But you see, biology is based on biochemistry, and biochemistry is based on quantum chemistry. Without the quantum properties of our molecules, we wouldn't be alive and there would be no evolution. It's safe to say. The visible world is Maya. It's a system of tricky deceptions, like the commercials of a big company or the statement of a government, not our government. The visible world instructs us and deceives us. You have to be smart not to fall for its tricks. To some extent, the classical scientists, they weren't smart. They told us that we should always look at the surface of things to understand the world. Make your own experiment. Look around. See, what do you see? You see things, you see matter, you see something hard and lasting stuff. So Newton was right when he said, God in the beginning formed matter in solid, massy, hard, impenetrable particles, so very hard never to wear or break in pieces. They are eternal. Particles are not eternal. When an elementary particle or an atom or a molecule is on its own in a vacuum, it leaves the material state and makes a transition into a wave state. The waves are described by Schrödinger's mechanics. They don't have units of mass, they don't have units of energy, they are just numbers, they are forms, they're information. The things practically leave the empirical world and enter a realm of information. Yeah, in this wonderful book, Infinite Potential, I have introduced this term of ET. The elementary things, ETs, the elementary thoughts, and all of them are entities. That's maybe a little bit going too far, but okay. So, to be a thing and to be a thought, these are two different states of an ET, of an entity. C.N. Villars is a British physicist. He has written several important papers. They are not quoted very often. He says microphysical objects are waves of potential observation interactions. They form a realm of potentiality that means not of the visible world. Behind the visible world is a realm of potentiality. Doesn't consist of things. It consists of forms, information. Yeah, you can look at it this way. When we see a particle, when it interacts with its environment, it's a dot. When we leave it alone, it becomes a wave. Interaction turns the wave into a particle. Isolation turns the particle into a wave, spontaneously. I will not talk about this. The waves can cause interference phenomena. We talked about that before, because they spread out in space and so on. This is a very special instrument. It is an electron diffraction instrument. It was designed and constructed by scientists and students in my research group in the 80s of the last century. It was very special. It was the first instrument that recorded electrons electronically rather than photographically. And that made possible new types of experiments, namely time-resolved experiments of laser-excited molecules. Yeah, I thought, you may never have seen such a thing, so it's fun to look at it. These are things, like a dishwasher, or what, they're objects. So when an electron enters such a thing, it becomes a wave. It enters it as a wave. And you can see how these waves interact with molecules. What does it mean? Now, here, you have to be careful. The pioneers, they have discovered wonderful things. They deserve our admiration. That doesn't mean they didn't say nonsense also. They're human. So they were kind of overwhelmed. You hear many people talk about wave-particle duality. Nonsense, there is no duality. There are wave states, there are particle states. It's like water. You can drink it when it is a liquid, you can suck it when it is ice. We don't speak of ice, liquid, water duality. Or even worse, observation creates reality. What nonsense, I'm sorry. There is always a reality, but it is invisible. It is an invisible reality. When it interacts with its environment, a visible particle can come out. So, Werner Heisenberg concluded, modern atomic theory no longer allows any naive materialism. That's a general rule. It also applies to biology. But somehow, biologists think they're special. They don't like it. For example, look at this quote from 1999. Kenneth Miller is a distinguished biologist. His book is a fascinating book, Finding Darwin's God. In there he writes, science is mechanism and materialism. And all that Darwin did was to show that mechanism and materialism apply to biology too. If biology students learn that in their formative age, are we amazed that later on they believe everything is material? Connected with such views is a claim that the molecules of biology, they are too large to be quantum systems. But what a nonsense. Huge molecules, for example, chlorophyll, hemoglobin, they have colors. They're huge molecules, 30,000 times heavier than a hydrogen atom. The color of your blood is red. Why can they have color? Because they can absorb certain frequencies or quanta out of sunlight. What do they do with this? They make quantum jumps. Color shows biomolecules have quantum states. Other aspects we find in the structures of proteins. Also in the 80s, researchers in my group performed the first quantum chemical calculations of the structures, so-called ab initio calculations, of the structures of peptides. At the time, those were giant calculations. Calculating a single structure cost more than $1 million in computing time. It was crazy. But there were some interesting results because they allowed us to predict structural trends in proteins that had never been observed before. Something like this, changes in bond lengths or bond angles depending on the form of a protein. Why had these things not been observed before? When I talked to protein crystallographers at that time, they usually looked at me with a pitying smile, and they said something like, "Do you really believe your stupid calculations have something to say about proteins?" I said, "Yes, I believe it." Why had these things not been observed? Because the experimental tools at that time weren't precise enough. In the next 10 years, they evolved, they became more precise, and lo and behold, the same trends you see there were found both in the experiments as we had calculated. So, okay, at this point you might say, yeah, fine. Proteins, biomolecules, they're quantum states. Why do I care? I had a nice lunch. We may have a nice dinner. It will turn out later. It don't matter. But the thing is, important aspects of our nature and its evolution are missed if we neglect the quantum nature of its molecules. For example, an important question in genetics is this. Yeah, we heard today. Can genetic mutations be random? Can they just happen like this? It was discussed earlier today. Richard Dawkins writes about it. He says, yes, that is a very important question. He gives a long discussion, and then he says, mutations are caused by definite physical events. They don't just spontaneously happen. I'm so sorry. But, there are quantum systems. During the synthesis of a gene molecule makes countless quantum jumps, again and again and again. It is an undeniable principle of quantum physics that quantum jumps can happen spontaneously without any cause. Stephen Hawking, many people have written about it. Stephen Hawking and Leonard Mlodinow recently, they write, according to quantum physics, the outcomes of physical processes cannot be predicted with certainty because they are not determined with certainty. Oh, the synthesis of a gene, the outcome cannot be predicted? Because that's very interesting. So this situation of quantum randomness leads us to a puzzle, and that is nothing in the visible, in the empirical world, is random. Everything has a cause. Only at the quantum level do we find processes which seem to be random. Could it be that their randomness is only an apparent randomness? Actually, it was my idea until I found that James Jeans already had this idea in the 30s. He said quantum indeterminacy may be no indeterminacy at all because it is a sign that quantum events depend on processes that occur in an invisible world and we don't know them. So, does that mean the molecules in your body are controlled by processes in an invisible world? How nice. Superposition states. It's a fundamental principle of quantum physics that if a system can exist in two states, psi 1 and psi 2, then it can also exist in both states at the same time. So you have a sum, psi 1 plus psi 2. That's a superposition. It's maybe a little bit abstract. I'll give you an example. When a car is traveling on the Pacific Highway, basically it has two states. It can go north or south, a real car. A quantum car can go north and south, but it can also be in a superposition where it goes north and south at the same time. Needless to say, you cannot see such a state, because when you look at it, you destroy it. One of the two possible states pops out. So, in a superposition state, a system has left the empirical world. For scientists, it seems to have been a scandal. No, there is a non-empirical world. We should just face it. The molecules in your body, they are in a constant, frantic dance in and out of superpositions, in and out of the empirical world. No scientist can know what happens to a system when it does not belong to the empirical world. All kinds of things can happen. In its molecular basis, the evolution of life may be instructed by a hidden order, a transcendent order of the universe. If you say, okay, proteins don't do that, fine. The molecules around them, they are messenger molecules. They can do it. The small molecules can do it. So here's my definition of evolution. It's very interesting. I'm glad I submitted that weeks ago because we heard the same kind of thing today. Evolution, I think, is the adaptation of life forms to increasingly complex forms in the cosmic potentiality. Something like this we heard today. So, worldview matters. The wrong view of the world leads to the wrong life. Newton's materialism was, of course, a huge success. Think of all the technological advances that came out of it. But when Darwin applied it, entered it into biology, he made a mistake. Having or not having stuff became the essence of life. And with this, greed and aggression became the natural virtues and the pillars of our society. But your inner potential, you have an inner potential. It is much more powerful than that. It can move you to acts of true human kindness. You just have to believe it, just try it. Quantum science is a form of mysticism. It brings us in contact with the transcendent world. If you want to be creative, your mind has to leave the empirical world. It's like if a flower wants to bloom, it has to leave its pot. So already the Indian sages taught us that the universe is filled with waves, spanda. The visible world is coming out of it. A beautiful image. This defines our voyage in this world. It is the sailing through spanda and towards the light. Sometimes the sailing can get a little bit rough, but that makes fun too. In general, it is beautiful. It's just, isn't that beautiful? So it's a sailing through spanda to the light. Now, at the end of my book, I describe how behind the visible surface of things is an ocean of possibilities. It is that ocean that defines your infinite potential. Its waves are playful. They dare you, they tease you. They play a game of hide and seek with you, but really they want you to catch one and turn it into a wonderful poem or a painting or a wonderful act of human kindness. Now, good books need good friends. Get that? Thank you very much.
So I think we've had a very rich day, and I thank you all for having the patience to sit through it. But I think it's time to question dogma right now. The prevailing dogma, the world is physical, evolution is mechanistic, mutations are random. And I think this was a fitting close because what you essentially said is the evolution of species is actually the evolution of forms of potentiality.
Yes, and maybe even mental.
And mental.
Yeah. And by the way, before I say anything, that is the best hug I had all day.
Okay, thank you.